There is no maximum burial depth specified in the National Electrical Code, or NEC, for low-voltage duct banks. However, several factors need consideration when determining the appropriate burial depth. Firstly, soil conditions matter. The type of soil and its moisture content can affect the depth at which the duct bank should be buried. For example, duct banks installed in sandy or loose soil may need to be buried deeper than those installed in clay or rocky soil. Secondly, consider groundwater. The presence of groundwater can also affect the burial depth. Duct banks installed in areas with high water tables may need to be buried deeper to prevent flooding. Thirdly, traffic is a factor. The amount of traffic in the area where the duct bank is installed can also be a factor. Duct banks installed in areas with heavy traffic may need to be buried deeper to protect them from damage. In general, it is recommended to bury low-voltage duct banks at least 18 inches below grade. However, in areas with severe soil conditions or other factors that could affect the duct bank, it may be necessary to bury it deeper. When planning to bury a low-voltage duct bank 5 feet below grade, this is generally a sufficient depth for most applications. However, it is important to consider the factors discussed above to ensure that the duct bank is properly protected. For example, if the soil is very loose or if there is a high water table, it may be necessary to bury the duct bank deeper than 5 feet. Similarly, if the duct bank is located in an area with heavy traffic, it may also be necessary to bury it deeper. The National Electrical Code provides minimum requirements for electrical installations. While the NEC doesn't specify a maximum burial depth for low-voltage duct banks, it's crucial to understand that exceeding a reasonable depth may lead to other practical challenges. These could include increased installation costs due to more extensive excavation, difficulties in future maintenance or repairs, and potential issues with heat dissipation if the cables are buried too deep and the surrounding soil acts as an insulator. When dealing with electrical installations, always refer to the most current edition of the NEC and consult with qualified electrical engineers or inspectors. They can provide valuable insights and ensure compliance with all relevant codes and standards. While the NEC provides a framework, local codes and regulations may have additional requirements or restrictions. It's essential to be aware of these local rules and adhere to them strictly. In addition to burial depth, other factors contribute to the overall safety and reliability of a duct bank installation. These include the type of conduit used, the spacing between conduits, the backfill material, and the methods used to seal the ends of the duct bank to prevent water from entering. The choice of conduit material is influenced by factors like soil conditions, potential for corrosion, and the need for mechanical protection. Common conduit materials include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and rigid polyvinyl chloride conduit. Each material has its advantages and disadvantages in terms of cost, durability, and ease of installation. Proper spacing between conduits is crucial to allow for adequate heat dissipation. Overheating can reduce the lifespan of cables and potentially lead to electrical failures. The NEC provides guidelines for conduit spacing based on factors like cable size, ampacity, and ambient temperature. The backfill material used to surround the duct bank plays a vital role in protecting the conduits from damage and providing a stable foundation. Common backfill materials include sand, gravel, and crushed stone. The backfill material should be free of sharp objects that could damage the conduits. Sealing the ends of the duct bank is essential to prevent water from entering. Water can damage cables and conduits, leading to electrical failures. Common sealing methods include using duct plugs, sealing compounds, and heat shrink tubing. Proper grounding is also crucial for the safety of a duct bank installation. Grounding helps to protect people from electrical shock and equipment from damage due to fault currents. The NEC provides detailed requirements for grounding electrical systems. These requirements cover topics like grounding electrode systems, equipment grounding conductors, and bonding. Regular inspections and maintenance are essential to ensure the continued safety and reliability of a duct bank installation. Inspections should be performed periodically to check for signs of damage, such as cracks in the conduits or water intrusion. Maintenance activities may include cleaning the conduits, repairing damaged sections, and replacing worn-out components. Remember that electrical work can be dangerous, and it's always best to hire a qualified electrician for any electrical installation or repair. Electricians have the training, experience, and equipment necessary to perform electrical work safely and correctly. When working with electricity, always follow safe work practices, such as wearing appropriate personal protective equipment, the energizing circuits before working on them, and using insulated tools. The NEC is a comprehensive document, and it's not always easy to understand. If you have questions about the NEC, consult with a qualified electrical engineer or inspector. It can help you interpret the code and ensure that your electrical installations comply with all applicable requirements. Understanding the specific requirements for your project and consulting with qualified professionals are essential steps in ensuring a safe and reliable electrical installation. Always prioritize safety and compliance with all applicable codes and standards. When planning the installation of a low-voltage duct bank, you need to perform a thorough site assessment. This assessment should include identifying any potential hazards, such as underground utilities, buried pipelines, or contaminated soil. Contacting local utility companies before digging can prevent accidental damage to underground utilities. Soil testing can help determine the type of soil and its moisture content. This information is essential for selecting the appropriate conduit material and determining the burial depth. Consider the long-term maintenance of the duct bank during the design phase. Providing access points for inspection and repair can save time and money in the future. These access points can be manholes or handholds placed at strategic locations along the duct bank. Document the location of the duct bank and all its components. Accurate records can be invaluable for future maintenance and repairs. These records should include detailed drawings, photographs, and descriptions of all materials and installation methods used. Conduct regular inspections of the duct bank to identify any potential problems early on. These inspections should include visual checks for damage such as cracks in the conduits or water intrusion. Also, monitor the temperature of the cables inside the duct bank to ensure they are not overheating. If you identify any problems, take prompt corrective action. Ignoring problems can lead to more serious damage and potentially create safety hazards. When repairing a duct bank, always follow safe work practices and use appropriate materials and methods. Ensure that the repaired section is properly sealed to prevent water intrusion. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified electrical engineers or inspectors for specific recommendations tailored to your project. Staying informed about the latest industry standards and best practices is essential for ensuring the safety and reliability of electrical installations. Participating in continuing education courses and attending industry conferences can help you stay up to date on the latest developments. By carefully considering all the factors involved and following the recommendations of qualified professionals, you can ensure that your low-voltage duct bank installation is safe, reliable, and compliant with all applicable codes and standards. Remember that a well-designed and properly installed duct bank can provide years of trouble-free service. In addition to the physical aspects of the installation, consider the electrical characteristics of the cables being installed in the duct bank. Ensure that the cables are properly sized for the load they will be carrying and that they are protected by appropriate overcurrent devices, such as circuit breakers or fuses. The NEC provides detailed requirements for cable sizing and overcurrent protection. Adhering to these requirements is essential for preventing overheating and potential fire hazards. Also, consider the potential for electromagnetic interference or EMI from other electrical equipment in the area. EMI can disrupt the performance of sensitive electronic devices. If EMI is a concern, use shielded cables and conduits to minimize interference. When installing cables in a duct bank, follow the manufacturer's instructions carefully. Proper cable installation is essential for ensuring reliable performance. Avoid bending cables too sharply, as this can damage the insulation and reduce their lifespan. Also, use cable lubricants to make it easier to pull cables through the conduits. After the duct bank installation is complete, perform thorough testing to verify that it is functioning properly. This testing should include insulation resistance tests, continuity tests, and voltage drop tests. The results of these tests should be documented and kept on file. The longevity and reliability of a duct bank installation are significantly influenced by the quality of the materials used. Selecting high-quality conduits, cables, and accessories can prevent premature failures and reduce the need for costly repairs in the future. When choosing conduit materials, consider factors such as corrosion resistance, mechanical strength, and ease of installation. For cables, look for products that are designed for underground use and that have a proven track record of reliability. Using substandard materials to save money can be a costly mistake in the long run. Over time, they can degrade and fail, leading to expensive repairs and potential safety hazards. Investing in quality materials from the outset can provide peace of mind and ensure that your duct bank installation will provide years of trouble-free service. Furthermore, consider the environmental impact of your duct bank installation. Use environmentally friendly materials and construction practices whenever possible. For example, consider using recycled materials for the conduits and backfill. Also, minimize the amount of disturbance to the surrounding environment during construction. Replant vegetation and restore the site to its original condition after the installation is complete. Being environmentally responsible can help protect the planet and improve the quality of life for future generations. When planning a low-voltage duct bank installation, consider the potential for future expansion. Designing the duct bank with extra capacity can make it easier to add new cables in the future without having to dig up the entire system. This can save time and money in the long run. One way to provide extra capacity is to install larger conduits than are currently needed. This will allow you to pull additional cables through the conduits in the future. Another way is to install extra conduits that are not currently being used. These spare conduits can be used for future expansion. When designing a duct bank for future expansion, consider the location of potential future loads. Place the duct bank in a location that will allow you to easily connect to these loads in the future. This may involve running the duct bank along existing roadways or through easements. Consider the aesthetics of the duct bank installation. While functionality is the primary concern, it is also important to consider how the duct bank will look in its surroundings. If the duct bank is located in a visible area, try to minimize its visual impact. One way to do this is to use landscaping to screen the duct bank from view. Another way is to use decorative materials for the manholes and handholds. Consider the security of the duct bank installation. Protect the duct bank from vandalism and theft. One way to do this is to install fences around the manholes and handholds. Another way is to use security cameras to monitor the area. When planning a duct bank installation, it is important to consider all of these factors to ensure that the installation is safe, reliable, and aesthetically pleasing. By carefully planning the installation, you can avoid potential problems and ensure that the duct bank will provide years of trouble-free service. After the installation is complete, document all aspects of the project. This documentation should include detailed drawings, photographs, and specifications of all materials used. This documentation will be invaluable for future maintenance and repairs. Also, keep a record of all inspections and maintenance activities. This record will help you track the performance of the duct bank over time and identify any potential problems early on. By keeping accurate records, you can ensure that the duct bank is properly maintained and that it will provide years of reliable service. In conclusion, installing a low-voltage duct bank requires careful planning and attention to detail. By considering all of the factors discussed above and following the recommendations of qualified professionals, you can ensure that your duct bank installation is safe, reliable, and compliant with all applicable codes and standards.